Summer 1943. A captured Japanese bomber sits on an American airfield in the Pacific. The aircraft is intact, mostly. Bullet holes perforate the wings and fuselage, but the structure remains sound enough for examination. American pilots and engineers gather around this strange machine. They have fought against these bombers for nearly 2 years, shot down dozens of them, watched them explode in midair with disturbing frequency. But this is the first time they have been able to examine one up close. The team begins their inspection. They examine the wings first. That is where American pilots have learned to aim. Hit the wings and the Betty burns, every time, without exception. The engineers expect to find fuel tanks. They do, but what they find next makes them stop. Makes them look at each other in confusion. Makes them call for senior officers. The fuel tanks have no protection, no armor plating, no self-sealing mechanism. Nothing. Just thin aluminum skin between thousands of gallons of highly flammable aviation fuel and enemy bullets. One American pilot who has shot down 3 Bettys examines the wing structure. He runs his hand over the tank. He can feel the fuel sloshing inside. He looks at his commanding officer and says something that will be recorded in the official report. "Sir, this is suicide. Whoever designed this aircraft sent their own men to die." This is the story of the Mitsubishi G4M Betty bomber, the aircraft that American pilots called the Flying Lighter, the Flying Zippo, the One-Shot Wonder, and the story of how American engineers, examining captured examples, could not comprehend the design philosophy that created it, a philosophy that valued range over survival, performance over protection, strategic capability over crew safety. This is the story of engineering choices, and the men who paid for them with their lives. U.S. pilots examined a captured Betty bomber and couldn't understand why it had unprotected fuel tanks. This is not simply a story about poor engineering. This is a story about 2 completely different philosophies of warfare meeting in the sky, and only one surviving. The Mitsubishi G4M Betty bomber was one of the most produced and most used Japanese aircraft of World War II. Over 2,400 were built between 1941 and 1945. It served in every major Pacific campaign, from the attack on Pearl Harbor to the final days of the war, when 2 white-painted Bettys carried Japanese surrender delegates to meet General MacArthur. The Betty was designed to be a long-range bomber torpedo carrier. Its specifications, when introduced in 1941, were extraordinary. A range of over 3,000 miles, a top speed of 265 miles per hour, the ability to carry an 1,800-pound torpedo or equivalent bomb load. These specifications exceeded most contemporary bombers. The B-25 Mitchell, introduced the same year, had a range of only 1,350 miles, less than half the Betty's range. The British Wellington bomber could manage 2,550 miles, still significantly less. The Betty could strike targets that no other medium bomber in the world could reach. This gave Japan enormous strategic flexibility in the vast distances of the Pacific theater. But this capability came at a price, a terrible price. To achieve this exceptional range, the Betty's designers made specific choices. They used lightweight aluminum alloys. They minimized structural reinforcement. They eliminated crew armor. And most critically, they chose not to install self-sealing fuel tanks or armor protection for those tanks. These choices reduced the aircraft's weight by approximately 1,500 pounds. That weight savings translated directly into additional range and payload capacity. The design philosophy was clear. Range equals strategic power. Strategic power wins wars. Therefore, maximize range at all costs. This philosophy was not unique to the Betty. The famous Mitsubishi A6M0 fighter used the same approach. exceptional range and maneuverability achieved by eliminating protection. Both aircraft dominated early Pacific combat, and both became death traps as the war progressed and Allied fighter tactics improved. American pilots noticed the Betty's vulnerability immediately. In early 1942, during battles over the Philippines and Netherlands East Indies, American fighter pilots discovered that Betty bombers caught fire easily. A few well-placed machine gun rounds into the wings, and the aircraft erupted in flames. Reports began filtering back to American intelligence. The Betty bomber burns, always, without exception. By mid-1942, American pilot training explicitly emphasized this vulnerability. Aim for the wings. Short bursts. The Betty will burn. Guaranteed. The nickname emerged organically among American fighter pilots. The Flying Lighter. Some called it the Flying Zippo, after the popular American cigarette lighter brand. The one-shot lighter became common. One shot, one lighter. One burst of fire into the wings, and the Betty became a torch. Japanese pilots knew this too. They had their own nickname for the aircraft. Hamaki, the cigar, a reference to the Betty's distinctive cylindrical fuselage shape, but also a darkly ironic reference to its tendency to burn. Some Japanese pilots called it the Type 1 lighter, a bitter play on its official designation as the Type 1 land attack aircraft. When American forces finally captured intact Betty bombers in 1943, engineer teams examined them thoroughly. The goal was to understand Japanese aircraft design and manufacturing capabilities. But what they found shocked them. Not because Japanese engineering was poor, but because it was deliberately lethal to its own crews. To understand why the Betty was designed the way it was, we must understand the strategic situation Japan faced in the late 1930s. Japan was building an empire across the Pacific and into China, but this empire covered vast distances, thousands of miles of ocean, hundreds of islands, mainland territories in China and Southeast Asia. The Japanese Navy needed an aircraft that could project power across these distances, that could strike enemy positions far from Japanese bases, that could strike enemy shipping lanes across the Pacific. In 1937, the Imperial Japanese Navy issued specifications for a new, twin-engine, land-based attack bomber. The requirements were ambitious, almost impossibly so. The aircraft must achieve a top speed of at least 247 miles per hour. It must cruise at 10,000 feet altitude. It must have an unloaded range of at least 2,934 miles. And it must have a loaded range carrying an 1,800-pound torpedo of at least 2,300 miles. These specifications exceeded most contemporary bombers. The American B-25 Mitchell, introduced the same year, had a range of only 1,350 miles, less than half the Betty's range. The British Wellington bomber could manage 2,550 miles, still significantly less. The Betty could strike targets that no other medium bomber in the world could reach. This gave Japan enormous strategic flexibility in the vast distances of the Pacific theater. But this capability came at a price, a terrible price. To achieve this exceptional range, the Betty's designers made specific choices. They used lightweight aluminum alloys. They minimized structural reinforcement. They eliminated crew armor. And most critically, they chose not to install self-sealing fuel tanks or armor protection for those tanks. These choices reduced the aircraft's weight by approximately 1,500 pounds. That weight savings translated directly into additional range and payload capacity. The design philosophy was clear. Range equals strategic power. Strategic power wins wars. Therefore, maximize range at all costs. This philosophy was not unique to the Betty. The famous Mitsubishi A6M Zero fighter used the same approach. exceptional range and maneuverability achieved by eliminating protection. Both aircraft dominated early Pacific combat, and both became death traps as the war progressed and Allied fighter tactics improved. American pilots noticed the Betty's vulnerability immediately. In early 1942, during battles over the Philippines and Netherlands East Indies, American fighter pilots discovered that Betty bombers caught fire easily. A few well-placed machine gun rounds into the wings, and the aircraft erupted in flames. Reports began filtering back to American intelligence. The Betty bomber burns, always, without exception. By mid-1942, American pilot training explicitly emphasized this vulnerability. Aim for the wings, short bursts, the Betty will burn, guaranteed. The first relatively intact Betty captured by American forces was recovered in mid-1943 from an airfield in the Solomon Islands. The aircraft had been damaged in a raid but remained structurally sound. American intelligence teams recognized the value immediately. Here was an opportunity to examine Japanese bomber design in detail. The aircraft was transported to a secure facility. Engineers from Wright Field in Ohio were flown in. Pilots with Betty combat experience were consulted. The examination began. The first thing engineers noticed was the overall construction quality. The Betty was well built. Manufacturing tolerances were precise. Welds were clean. Riveting was professional. This was not a hastily produced aircraft. It was engineered and manufactured with care. The fuselage structure impressed the engineers. The oval cross-section was innovative. It provided significant internal space while maintaining aerodynamic efficiency. The frames and stringers were well designed. Load paths were logical. The landing gear impressed them as well. The mechanism was robust. Retraction was simple but effective. The gear could clearly handle rough field operations. The engines, when examined, showed sophisticated engineering. The Mitsubishi Kase radial engines were well designed, comparable to American radials like the Wright Cyclone. Japanese metallurgy was clearly advanced. But then the engineers examined the fuel system, and confusion began. The wing structure was opened carefully, the fuel tanks were exposed, and the engineers saw something they initially thought was an error. Thin aluminum tanks, no armor, no self-sealing construction, just simple metal tanks holding aviation fuel. One engineer asked if perhaps this was a training aircraft. Training aircraft sometimes lacked protection that combat versions included. But this was a combat aircraft, recovered from a combat zone, showing battle damage, not a trainer. Another engineer suggested maybe the Japanese had removed the protection to save weight after the aircraft was damaged, to make it easier to fly back to base. But examination of the manufacturing showed this was original construction. The aircraft was built this way, deliberately. A senior engineer who had worked on American bomber design was called in. He examined the fuel tanks carefully. He measured the aluminum thickness. He checked for any fire suppression system, any redundant fuel lines, any safety features. There were none. He looked at the assembled team and said something recorded in the official examination report. "Gentlemen, this aircraft's fuel system is essentially unprotected. A single machine gun bullet penetrating this tank would likely cause catastrophic fuel leakage. The fuel would immediately vaporize in the high-speed airflow. Any ignition source, a tracer round, hot engine components, electrical sparking, would cause immediate ignition. This aircraft would become a flying bomb." The team calculated the vulnerability. The wing tanks occupied approximately 40% of the wing's frontal area. Any fighter attacking from the side had a 40% chance of hitting a fuel tank with random fire. Against coordinated gunfire aimed at the wings, the probability approached 100%. One pilot consultant explained what this meant in combat. "We aim for the wings because that is where the tanks are. 3 to 5 seconds of fire from 6 50-caliber machine guns, perhaps 50 to 100 rounds connect with the aircraft. Of those, 10 to 20 will penetrate the wings, and that is all it takes. The Betty explodes or catches fire. Every single time." The engineers could not understand the design logic. American bombers used self-sealing tanks.
The technology was not new, it had been developed in the 1930s. Self-sealing tanks used multiple layers, an outer layer of vulcanized rubber, a middle layer of absorbent material, an inner lining that swelled when exposed to fuel. When a bullet penetrated the tank, the fuel would cause the inner lining to swell. The absorbent layer would expand, the hole would seal within seconds, not perfectly, but enough to prevent catastrophic fuel loss, and enough to prevent fuel vaporization and ignition. American aircraft also used armored fuel tanks, steel plating around critical fuel systems positioned to protect against the most likely attack angles. This added weight, approximately 800 to 1,200 pounds, depending on the aircraft, but it dramatically improved survivability. American bombers could take hits to the fuel system and continue flying. They could return to base despite damage. Crews survived to fly again. The Japanese had chosen differently. The examination report was brutally frank in its conclusions. The Mitsubishi G4M bomber achieves its exceptional range through extreme weight savings. These savings are realized primarily through the complete elimination of crew and fuel tank protection. The resulting vulnerability is severe. The aircraft is estimated to be 3 to 5 times more likely to be destroyed by defensive fire compared to equivalent American bombers. This design philosophy prioritizes strategic range over tactical survivability. It assumes that range and speed will prevent interception. In early war conditions against unprepared opponents, this assumption proved valid. But against prepared defenses with modern fighters, this design philosophy is lethal. Japanese crews flying this aircraft face drastically reduced survival probability compared to American bomber crews. The report recommended several things. First, American fighter pilots should continue to target Betty wings. The vulnerability was real and should be exploited. Second, American bomber design should continue to prioritize crew protection. The Betty's approach, while achieving impressive range, was ultimately self-defeating. Third, intelligence officers should seek to understand why Japanese designers made these choices. Was it a resource limitation, a cultural difference, a miscalculation of combat conditions? Understanding the enemy's design philosophy could provide insight into their broader strategic thinking. But beyond these tactical and strategic recommendations, the American engineers were left with a deeper question, a question that troubled them. How do you send men into battle in an aircraft you know will burn? How do you ask crews to fly a machine that offers them almost no protection? How do you look a pilot in the eye and tell him to climb into what amounts to a flying fuel tank wrapped in thin aluminum? The Americans could not comprehend it. Not because they lacked technical understanding, but because their cultural and ethical framework could not accept that trade-off. American military culture emphasized bringing soldiers home, protecting your people, giving them the best equipment possible. Taking calculated risks, yes, but not sending men to near certain death unnecessarily. The Betty represented a different philosophy, one the Americans could analyze technically, but could not understand philosophically. This was perhaps the greatest revelation of the examination. Not the technical details, but the recognition that they were fighting an enemy who thought about warfare in fundamentally different terms that were alien and disturbing to American sensibilities.
The technical analysis told one story. The combat statistics told another. And the statistics were devastating. Between 1942 and 1945, approximately 2,400 Betty bombers were produced. By the end of the war, fewer than 50 remained operational. The vast majority had been destroyed in combat. The loss rate was staggering. In some operations, Betty formations suffered casualty rates exceeding 50%. Half the aircraft sent on a mission never returned. Compare this to American bomber operations. The B-17 Flying Fortress, operating over Europe in the most intense air combat of the war, suffered overall loss rates of approximately 5% per mission. Yes, individual missions sometimes saw higher losses. The Schweinfurt raids saw losses approaching 20%. But these were exceptional. The Betty's loss rates were routine. The first major indication of the Betty's vulnerability came during the Guadalcanal campaign in August 1942.
Japanese forces were attempting to retake Henderson Field on Guadalcanal. Betty bombers operating from Rabaul over 500 miles away flew daily bombing missions against American positions. The distance was enormous. The missions required the Betty's full range capability. No other Japanese bomber could make the round trip. But American fighter pilots flying F-4F Wildcats initially and later F-4U Corsairs learned to intercept these raids. The combat pattern became predictable. Japanese formations would approach at altitude, American fighters would climb to intercept, the Bettys would maintain formation, relying on mutual defensive fire, and then the shooting would begin. American pilots quickly learned the Betty's weakness: aim for the wings, short, controlled bursts. 6 50-caliber machine guns could pump out over 4,000 rounds per minute combined. Even a 3-second burst meant 200 rounds fired. Of those 200 rounds, perhaps 20 to 40 would hit the target aircraft. Of those hits, 5 to 10 would penetrate the wings where the fuel tanks were located. That was enough. The Betty would stream fuel. The vaporized fuel would ignite from tracer rounds or hot metal. Fire would spread instantly through the wing structure. Within seconds, the entire wing would be engulfed. The aircraft would lose lift asymmetrically. It would roll violently, and it would fall from the sky, trailing smoke and flame. Sometimes the aircraft would explode in mid-air. The fuel tanks would rupture catastrophically. The fuel-air mixture would find an ignition source, and 1,200 gallons of aviation fuel would detonate. The explosion would be visible from miles away. Pieces of the aircraft would scatter across thousands of feet of sky. No survivors, no chance of survival. The American pilots called it flaming. A Betty had been flamed. The term became common radio chatter during missions. Betty flaming at 3 o'clock high. Splash to Betty, she's flaming. 2 Bettys down, both flaming. The statistics from Guadalcanal operations were brutal. Between August 1942 and February 1943, Japanese Betty units lost over 100 aircraft in the Solomons Theater. This represented approximately 1/3 of all Bettys in frontline service at the time. Replacement aircraft and crews were rushed forward, but the loss rate continued. New crews arrived, they flew a handful of missions, and they died. The average operational life of a Betty crew in the Solomons was measured in weeks, not months, weeks. Some crews were lost on their first mission. Others survived 2 or 3 missions. A crew that survived 5 missions was considered experienced. 10 missions was rare. 20 missions was almost unheard of. Japanese air crews began to understand what they were facing. They were being asked to fly a machine that could not protect them, that would burn at the first touch of enemy fire, that offered them almost no chance of survival if intercepted. One Japanese Betty pilot, Petty Officer Sakaida Saburo, survived the Guadalcanal campaign and later wrote about his experience. His account provides insight into what crews were thinking. We knew the Betty would burn. Everyone knew. The Americans called it the one-shot lighter. We called it Hamaki, the cigar, because it looked like a cigar and burned like one too. Before each mission, we would say goodbye to each other. Truly goodbye, because we understood that many of us would not return. The Americans had fast fighters now, F-4U Corsairs. They could catch us, and when they did, we burned. I flew 23 missions. I saw hundreds of men die. I watched them burn. I watched aircraft explode. I watched crews bail out with their clothing on fire. And I knew that any mission could be my last. Not might be, would be. It was only a matter of time. You could not stop it. You could only delay it. This was the reality that American engineers examining captured Bettys could not fully comprehend. They understood the technical vulnerability, but they could not imagine the psychological burden of flying such an aircraft, knowing its reputation. The Japanese Navy attempted to address the problem. In 1943, modifications were introduced with the G4M2 variant. This version included some fuel tank protection. Rubber coating on the main tanks, better fire suppression systems, slightly more armor around critical components. But these modifications were limited. The basic design could not be fundamentally changed without completely redesigning the aircraft. And Japan's industrial capacity was strained. Retooling for a new bomber design would take years and resources Japan did not have. The G4M2 improvements helped marginally, but the aircraft remained highly vulnerable. Loss rates decreased slightly, but they remained catastrophically high by any reasonable standard. American pilots noted the modifications. They adjusted their tactics. Aim for the engines instead of just the wings. Engine fires were almost as effective as fuel fires. The Betty continued to burn. By 1944, the strategic situation had turned decisively against Japan. American forces were advancing across the Pacific. Japanese air forces were being ground down through attrition. Experienced crews were being killed faster than they could be replaced. The Betty bore the brunt of these losses. It was used for everything: level bombing, torpedo attack, anti-shipping strikes, even long-range reconnaissance. And in every role, it died in large numbers. The Battle of the Philippine Sea in June 1944 saw Betty formations decimated. American carrier fighters, now including F-6F Hellcats, shot down Japanese aircraft at ratios exceeding 10-1. Bettys were easy targets, large, relatively slow, highly flammable. American pilots targeted them preferentially. Why engage agile fighters when you could shoot down bombers? One American F-6F fighter pilot, Lieutenant Alex Ryu, shot down 6 Japanese aircraft in a single engagement. 4 of them were Bettys. His after-action report described the engagement. The Bettys were in a loose formation at about 18,000 feet. I came in from above and behind, dove on the trailing Betty, opened fire at 300 yards, closed to 100 yards. My 650s walked up the fuselage and into the wing route. The Betty exploded immediately. Complete disintegration. Pulled up, rolled left, dove on the next Betty. Same approach, same result. This one caught fire instead of exploding. Dropped away trailing flame. Third Betty tried to break formation. I followed. Short burst into the port wing. Fires started immediately. The aircraft rolled inverted and spun in. Fourth Betty I hit in the starboard engine. The engine exploded, blew the wing off. The Betty went into an uncontrolled tumble. These aircraft are not survivable once you hit them. They burn or explode, every time. This was the combat reality. This was what American technical analysis had predicted, and this was what Japanese crews experienced every day. The Betty had been designed for a war that no longer existed. A war against unprepared enemies with limited fighter defenses. A war where range and payload mattered more than survivability. But by 1944, Japan was fighting a different war. A war against an enemy with vast industrial resources, with modern fighters in large numbers, with trained pilots and effective tactics. In this war, the Betty was obsolete. Not because its basic capabilities had diminished, but because the environment had changed, and the design philosophy that created it could not adapt.
Behind the statistics were individual stories. Men who flew the Betty, men who knew its reputation, men who climbed into that aircraft anyway because duty demanded it. The American examination of captured Bettys focused on technical details, but the human element was always present in the background. Every aircraft examined had carried a crew. Most of those crews were dead. The Betty required a crew of 7: pilot, co-pilot, navigator/bombardier, radio operator/gunner, 2 waist gunners, tail gunner. 7 men whose survival depended on an aircraft that offered them minimal protection. Japanese training emphasized spiritual strength and technical skill. Crews trained extensively. They learned their aircraft systems thoroughly. They practiced navigation. They rehearsed bombing and torpedo runs. They trained in formation flying and defensive tactics. But no amount of training could overcome the fundamental vulnerability of the aircraft they flew. This created a psychological burden unique to Betty crews. Other Japanese air crews faced danger. Fighter pilots flew aircraft with limited protection, but fighters were agile, fast, maneuverable. A skilled fighter pilot could evade enemy fire, could outmaneuver attackers, had agency in combat. Betty crews had no such advantage. Once intercepted, their survival depended entirely on whether American fighters chose to press their attacks. If the Americans attacked aggressively, the Betty would burn. The crew had no effective defense. Their guns could fire, but they rarely deterred determined fighter attacks. The Betty was too large a target, too slow, too flammable. Some Japanese Betty crews developed superstitions, lucky charms, rituals performed before each mission, prayers at Shinto shrines, letters written to family before takeoff. These were coping mechanisms, ways to manage the fear of flying an aircraft nicknamed the Flying Lighter by their own side. American intelligence officers who interrogated captured Japanese air crews noted this psychological burden. One report from 1944 stated, "Prisoners of war from Betty units consistently report low morale. They understand their aircraft's vulnerability. They know American fighters target Bettys preferentially. Many express relief at being captured. They prefer American prison camps to continued missions in the G4M. This represents a significant morale problem for Japanese naval aviation. The relief at being captured is telling. These were not cowards. They were trained military personnel who had volunteered for combat aviation, but they had been asked to fly missions in an aircraft they knew was a death trap, and capture offered escape from that fate. Some Japanese Betty pilots attempted to transfer to other aircraft types, fighter units, or even flying boats, which at least operated away from heavy fighter opposition. But the Navy needed bomber crews. Transfers were rarely approved. You trained on the Betty, you flew the Betty, you died in the Betty. That was the expectation. The Japanese pilot Saburo Sakai, who became one of Japan's most successful fighter pilots, wrote about this dynamic in his memoirs. He described watching Betty formations being slaughtered by American fighters. "We fighter pilots tried to protect them. We flew escort when possible, but there were never enough fighters. And the Bettys were so vulnerable. The Americans would break through our escort. They would hit the bombers, and the Bettys would burn. I watched it happen dozens of times. The bomber crews knew they were flying to their deaths, but they went anyway. This was their duty. I respected their courage, but I also thought their commanders were asking too much. Sending men into combat in aircraft that could not defend themselves was wasteful. It was not courage, it was waste." This criticism from a Japanese pilot is significant. It shows that even within Japanese military culture, which emphasized sacrifice and duty, there was recognition that the Betty's vulnerability crossed a line. That asking crews to fly such missions was not strategic necessity, it was institutional failure. The families of Betty crew members understood this too. When a young man was assigned to a Betty unit, his family knew the implications. The loss rates were not secret. Letters from the front described the situation. Communities where naval air bases were located saw the casualties. One Japanese mother, whose son flew as a Betty navigator, was interviewed after the war. Her account was recorded by occupation force historians, documenting Japanese wartime experiences. "When my son told me he was assigned to the Betty bomber unit, I knew he would not return. Everyone knew about the Betty. It was called the cigar because it burned. I did not tell him my thoughts. I encouraged him. I told him to serve honorably, to fulfill his duty. But inside, I was mourning him already. He flew 6 missions. On the 7th mission, his aircraft was shot down near Rabaul. No survivors. He was 23 years old. After the war, I learned more about the Betty bomber. I learned it had no protection for the fuel tanks, that American pilots called it the one-shot lighter. I became angry, not at the Americans, they were doing their duty. I became angry at the people who designed this aircraft, who sent my son and thousands of other sons to die in an aircraft they knew could not protect them. This was not honorable. This was criminal. This anger was not uncommon among surviving family members after the war. The technical justifications for the Betty's design made sense strategically. Range was important. But when your sons and brothers are dying in burning aircraft, strategic justifications ring hollow. The American engineers examining captured Bettys understood this human dimension intellectually. Their reports included estimates of crew survival rates. They calculated that a Betty hit in the fuel system had less than 10% crew survival rate. Compare this to American bombers. A B-17 or B-24 hit in the fuel system might suffer damage, might lose fuel, might have to abort the mission. But the crew's survival probability remained above 60%. The self-sealing tanks would contain the fuel leak. The armor would prevent fire. The redundant systems would keep the aircraft controllable. The crew could bail out safely or limp back to base. Many damaged American bombers made it home. Many American bomber crews survived being shot down. They were captured, spent time as POWs, but survived. Betty crews had no such advantage. When their aircraft was hit, they burned. If they survived the initial fire, they faced bailout from a burning aircraft at altitude. Many crews died in the bailout attempt. Burns, smoke inhalation, parachutes that failed to deploy properly due to panic or disorientation. Those who successfully bailed out often died on the way down. Fighter strafing of parachuting crew was not official American policy, but it happened. Some American pilots, enraged by Japanese atrocities or simply caught up in combat fury, shot at descending parachutes. Japanese Betty crews knew this was possible. It added another layer of horror to an already terrifying situation. The few Betty crew members who survived being shot down and reached the ground faced uncertain fates. If they came down in the ocean, their survival depended on rescue. Japanese search and rescue capabilities were limited. Many drowned before rescue could arrive. If they came down on enemy-held territory, they were captured, became POWs. Treatment varied. American forces generally followed Geneva Convention guidelines, but in the intense hatred of Pacific combat, not all prisoners were treated well. If they came down on Japanese-held territory, they might survive to fly again, to face the same fate on another mission. Some crews were shot down multiple times and survived. Each time, they returned to duty, climbed into another Betty, flew another mission, until their luck ended. One Japanese pilot, who survived the war flying 41 Betty missions, described this cycle. Each time I survived, I felt guilty. Guilty that I had lived while others died. Guilty that I would have to fly again, knowing the next mission might be the one where my luck ended. Some men broke under this stress. They could not fly. The shame of refusing duty was too great, but they could not climb into that aircraft again. Some took their own lives.
By 1945, Japan's situation was desperate. American forces controlled the Philippines.
B-29 superfortresses were bombing Japanese cities. The Navy was destroyed. The Air Force was a shadow of its former strength. And the Betty bomber force was effectively extinct as a strategic weapon. The few remaining operational Bettys were used for desperate missions: kamikaze support, special attack transport, long-range reconnaissance, missions where the aircraft's vulnerability was less critical because survival was not expected anyway. The Betty had come full circle. Designed as a strategic offensive weapon, it ended the war as a platform for suicide attacks. The Oka-piloted bomb program exemplified this final degradation. The Oka was a rocket-powered flying bomb. A pilot would guide it to the target, then ignite the rocket motors and crash into enemy ships. The Oka could not take off under its own power. It needed a carrier aircraft. The Betty was chosen for this role. A Betty would carry the Oka under its fuselage, fly to the attack area, release the Oka, then return to base, if it survived. This was the mission the Betty had been reduced to: carrying suicide bombs. The irony was bitter. The Betty itself was already considered a suicide aircraft by its own crews. Now it was literally carrying suicide weapons. The Oka missions had terrible loss rates. American fighters learned to intercept the Betty-Oka combinations before they reached the fleet. The heavily laden Betty was even slower and less maneuverable than usual, easy to shoot down. Most Oka missions never reached their targets. The carrier Bettys were shot down. The Oka pilots died without ever getting a chance to attack. The Betty crews died as well. Burned, exploded, disappeared into the ocean. By April 1945, the Oka program was essentially abandoned. Too many losses, too little success. The Bettys that remained were hoarded for even more desperate missions: individual kamikaze attacks, night harassment bombing, transport missions to isolated garrisons. On August 15, 1945, Japan surrendered. The war was over. The Betty bomber had flown its last combat mission, or almost its last. Two white-painted Bettys, stripped of weapons and marked with green crosses, were used to transport Japanese surrender delegates to meet American forces. These aircraft flew to Ieshima, then to Manila, carrying the officials who would arrange the formal surrender. It was fitting, in a way. The Betty had participated in the opening of the Pacific War, and it participated in the closing. But in between, it had earned a reputation as one of the most vulnerable bombers of the war, a reputation it deserved. A reputation bought with the lives of thousands of Japanese airmen. The final statistics were compiled after the war. Of approximately 2,400 Bettys produced, only 49 remained at war's end. Over 2,300 had been destroyed, lost in combat, lost to operational accidents, lost to the fundamental design flaw that made them flying fuel tanks. American intelligence estimated that over 15,000 Japanese airmen died in Betty-related operations during the war. Pilots, co-pilots, navigators, gunners, radio operators, bombardiers, 15,000 men. That is more than the total number of American Marines who died at Iwo Jima. All from one aircraft type. All because of design choices made in 1939 that prioritized range over survivability. The Japanese Navy conducted its own investigation after the war. Internal reports acknowledged the Betty's vulnerability. They documented the loss rates. They interviewed surviving crew members. The conclusions were damning. The Betty's design philosophy had been based on faulty assumptions. The assumption that Japanese forces would face weak opposition. The assumption that range alone could compensate for vulnerability. The assumption that formation tactics could provide adequate defense. All these assumptions proved false. The Betty had been an effective bomber for perhaps 6 months, from December 1941 to mid-1942. After that, it became a liability. But Japan's industrial capacity and strategic situation prevented developing a replacement. So, the Betty continued in service, and men continued to die. One post-war Japanese report stated bluntly, "The Type 1 land attack aircraft achieved its design goals of exceptional range and payload capacity. However, these capabilities were achieved at the cost of survivability. In the combat environment that actually developed, this trade-off proved catastrophic. The loss of experienced crews was unsustainable. The loss of aircraft production capacity was wasteful. The psychological impact on surviving crews was debilitating." If this aircraft were to be designed again with knowledge of actual combat conditions, the priorities would be reversed. Survivability first, then range. This represents a fundamental lesson in combat aircraft design. This was as close to an official admission of failure as Japanese military culture allowed. The Betty had been a mistake, an expensive, deadly mistake. The American engineers who examined captured Bettys had understood this truth in 1943. The Japanese Navy admitted it in 1946. But for the 15,000 men who died in flames, this acknowledgement came too late.
The story of the Betty bomber offers profound lessons about engineering, warfare, and the cost of strategic miscalculation. These lessons resonated through post-war aircraft design worldwide. The most obvious lesson is technical. Protection matters. Self-sealing fuel tanks, armor plating, redundant systems, fire suppression. These add weight. They reduce performance, they increase cost, but they save lives. Post-war bomber design universally incorporated protection features. The American B-47 Stratojet, the Soviet Tu-16 Badger, the British V-bombers all included comprehensive fuel tank protection. The age of unprotected fuel tanks was over. The Betty had taught that lesson definitively. But there is a deeper lesson about design philosophy. The Betty represented an extreme example of optimization for a single parameter, range. Everything else was sacrificed to achieve maximum range. This produced an aircraft that excelled at its design goal, but failed catastrophically when conditions changed. Modern systems engineering recognizes this trap. Over-optimization for a single parameter creates brittleness. When that parameter is no longer the most important factor, the entire system fails. Better to design for acceptable performance across multiple parameters. Robustness beats optimization. The Betty also taught lessons about crew morale and institutional responsibility. Sending men into combat in inadequate equipment is not strategic necessity. It is moral failure. A military organization has a responsibility to its personnel to give them the best equipment possible, to protect them as much as possible, to value their lives. The Japanese Navy failed this responsibility. They created an aircraft that prioritized abstract strategic goals over crew survival. They continued to deploy that aircraft even when its failure was obvious. They spent lives achieving minimal results. This was not the fault of Japanese culture or warrior ethos, it was institutional failure. American military leaders studying the Betty after the war took these lessons seriously. The U.S. Air Force made crew survivability a major design priority, even when it meant accepting reduced performance or increased cost. The B-52 Stratofortress, designed in the late 1940s, incorporated extensive crew protection, ejection seats, armor, self-sealing tanks, redundant systems. The B-52 was not the longest-range bomber possible, but it was designed to bring its crew home. This philosophy persists. Modern military aircraft design always includes survivability as a primary requirement. Stealth, electronic warfare, armor, redundancy, all aimed at protecting the crew. The Betty's legacy is a reminder of what happens when this principle is forgotten. There is also a legacy in popular culture. The Betty remains famous precisely because of its vulnerability. It appears in histories, documentaries, museums, books about the Pacific War, always described as the flying lighter, the one-shot wonder. This reputation overshadows its actual capabilities. The Betty could achieve things no other bomber of its era could. Its range was extraordinary. Its payload capacity was impressive. Its early war performance was effective. But none of that matters to popular memory. The Betty is remembered for burning. This is perhaps unfair to the aircraft itself, but it is appropriate to remember the men who flew it, their courage, their sacrifice, and the fact that much of that sacrifice was unnecessary. Better design choices would have saved thousands of lives. The handful of surviving Bettys in museums stand as monuments, not to technological achievement, but to the cost of flawed design philosophy, to the importance of protecting those who serve, to the recognition that human life must be valued even in war. American engineers examining captured Bettys in 1943 could not understand why Japan made the design choices it did. By 1945, even Japanese military leaders struggled to justify those choices. The Betty bomber taught expensive lessons, lessons bought with 15,000 lives, lessons that should never need to be learned again. In the end, the Betty represents a fundamental question about warfare and technology. How much can you ask of those who serve? What level of risk is acceptable? Where is the line between necessary sacrifice and criminal neglect? The Betty crossed that line. American engineers recognized it immediately. Japanese crews knew it from experience. Japanese commanders admitted it after the war. The Betty bomber was an engineering achievement that became a death trap, a strategic weapon that wasted more resources than it destroyed, an aircraft that should have been redesigned but instead continued in service long past its useful life. U.S. pilots examined a captured Betty and couldn't understand why it had unprotected fuel tanks. The answer, ultimately, was simple. Japanese designers chose range over lives, strategic capability over crew survival, abstract goals over human reality. This choice defined the Betty, and this choice killed thousands of men who deserved better.